Okay, now in my previous video we learned how to solve the eigenvalues and the eigenvectors in matrix, and I only focus on the eigenvalue in the previous video, and today we are going to be looking at the eigenvectors of matrix. Now remember that the question was given that A equals to 3, 4, 2, 1. Find the eigenvalue. That was the question, and you now get the answer. The eigenvalues were lambda equals to -1, comma lambda equals to 5. These are the eigenvalues for this matrix. Now remember that the formula we used was determinant A minus lambda in identity matrix equals to 0. Or you can also use this one, determinant A minus lambda times identity matrix equals to 0. Now, in this video we are not going to be using this formula. This formula, the reason is because we are looking for the eigenvector of this matrix. The matrix is A equals to 3, 4, then 2, 1. Now, and the formula for finding any eigenvector is going to be, let's say, A minus lambda and identity matrix and times x equals to 0. Now remember this formula. Now remember that I said for the distance, for the eigenvalues, it's going to be 3 minus lambda. If you remember very well, 4 minus 0, then 2 minus 0, 1 minus lambda equals to 0. Now, but in this case, we are not looking for the determinant. Now, what we are looking for is the eigenvector, so we don't need determinant. Now, what we need to understand is that the eigenvectors for lambda equals to -1 is going to be, now coming back to this case, we have 3 minus into brackets -1, we have 2, we have 4, we have minus into brackets -1 also, then times x1, x2 equals to 0. Now from this you can see that this is 4, this is 2, this is 4, and this is also 2. So we have x1, x2 equals to 0. So we have, now multiplication of matrices, 4 times x1 plus 4 times x2. Now you add it together, then 2 times x1, 2 times x2, you add it together, equals to 0. So we have 4x1 plus 4x2 equals to 0. 2x1 plus 2x2 equals to 0. This can be called equation 1, equation 2. Now, in both cases, I can quickly infer that x1 equals to minus x2. Now let's check from equation 1. We have 4x1 equals to minus 4x2. Now when I bring this positive 4x2 to this side, it becomes negative 4x2. So divide both sides by 4, say x1 equals to minus x2. Can we see that now? Now let's check that in equation 2. Let's check that in equation 2. So what do we have? We have in equation 2 now we have 2x1 plus 2x2 equals to 0. We have 2x1 equals to negative 2x2. Now how do we get this negative 2x2? You bring this positive 2x2 in, it becomes negative. We have both sides by 2. What do you have? We have x1 equals to minus x. The eigenvalue of lambda equals to -1 has generated the eigenvectors of lambda equals to -1 will be generated as x1 then x2, which is equals to 1 and -1. which is equals to 1 and minus 1. If that is taken, then we move to the lambda equals to 5, which is the second eigenvalue. If that is taken. Now, eigenvalue or eigenvector, eigenvector for lambda equals to 5 is going to be, now remember, I did that same method and that same procedure. We have 4 minus 0, we have 2 minus 0, we have 1 minus lambda, 1 minus lambda, then times x1 then x2 equals to 0. Now with that, now remember that the lambda is 5. So bringing in lambda, we have 3 minus 5, we have 2, we have 4, we have 1 minus 5, then x1, x2 equals to 0. We have minus 2, we have 2, we have 4, we have minus 4. So times x1, x2, which is equals to 0. Now, we are going to go back to that first multiplication, which is x2 times x1, then 4, minus 2 times x1, then 4 times x2. We add it together. So, for this one, it's minus 2x1 plus 4x1 equals to 0. This 0 here. This times this, 2x1 minus 4x2 equals to 0. Now, this is equation 1, this is equation 2. Now, in both cases, you can infer that x1 equals to 2 times x2. I'm going to show you that now. Now, from equation 1, what do we have? We have minus 2x1 equals to minus 4x1, x2. So divide both sides by minus 2. We have x1 equals to 2x2. Now, if from equation 2, we have 2x1 equals to 4x2. Divide both sides by 2. We have x1 equals to 2 times x2 in both cases. So if that is taken, if that is taken, then we move to the conclusion. The eigenvector for lambda equals to 5 is generated as x1, x2, which is, now remember, for any value of x1 here, it's going to be 2 times the value of x2, which means that this is 1 and this is 2. That is all. So thank you. We'll meet in our next video. So please, before that, subscribe to my channel. God bless you.